about a car that is trying to ascend a hill, okay? And this is a very simplistic illustration of the concept of homeostasis, as well as the players that are involved in homeostasis. So our car starts off at the bottom of the hill here on the left. And please excuse my car. It's kind of scratchy. There we go. So that's our car. Let's give him a window. And it starts off going at a rate of about 60 miles per hour. Okay, so that's the initial rate that we start off at. And because we're going to put on our cruise control, we're going to kind of dial in that 60 miles per hour as our set point. Okay, and so when we speak about set point, this is the mileage or the rate that the car is going to strive to maintain no matter what. So we're going to call this our set point. Now, as this car starts to ascend the hill, so it's going to get to the foot of the hill pretty much, and then gravity is going to take place. The effect of ascending that hill is going to kind of kick in, and the car is going to naturally decline in its speed, okay? And because it's going to decline in its speed, that is going to set off what we call an error signal. So we see here a decline in speed. The car is now going at about 55 miles per hour. And because that is not our set point, this is the miles per hour that we want to maintain, that we're going to strive to maintain, that automatically sets off what we call an error signal. Okay, because of this reduction in speed. Now, as a part of correcting this error signal, the next thing that's going to happen is the car is going to naturally, as a reaction, increase the gas flow to the engine. So here's our car again. And this time, because we've increased the gas flow to the engine, we've slightly sped up the car. So the car is now going, let's make a note of that. We increase the gas flow. To the engine. And that's going to result in an increase in speed. So because of that now, the car is now going at about 58 miles per hour. And because we're now starting to increase our speed, we're getting closer to our 60 miles per hour, then we're going to see a slight reduction in the error signal. So we see a slight reduction in the error signal here. And then eventually, as we get to the top of this hill, we see that our car now gets back to that 60 miles per hour speed rate, and our error signal is now turned off. So we're back to 60 miles per hour, and then here we see we're back to set point, so the error signal is turned off. Okay, so it's important to establish two things: that the set point is pretty much our basis, it's our normal. Anytime there's a deviation from the set point, that sends off an error signal. And the error signal is the trigger to get us back to our set point. So the error signal is going to be equivalent, the degree of the error signal is going to be equivalent to the difference between where we are and our set point, okay? So let's kind of try to represent this on a graph down here. Oops. So on the y-axis of our graph, we can put speed. That's in miles per hour. And then we're going to compare that to time. Okay. And let's kind of mark out our set point here on our graph. So that's where things are starting off. So that's about 60 miles per hour. And this is where we start off. So let's get, so this is our set point. At this point, we see a drop in the speed to about 55. And then we see a gradual increase until we get back up to 60, which is our set point once again. So what we really want to illustrate here is that as soon as we drop from our set point, we've got this error signal, and the error signal is going to be the degree to which we are away from our set point. So this is the difference here. And as we can see, this difference gets smaller and smaller until eventually the error signal is turned off. Okay, so here we've got the error signal on. And then down here, we turn off the error signal. Okay, so the important things I want to point out here is one, our set point, the fact that this is our baseline variable. Oops. And that is where we really want to maintain. So in the example here of our car, that's the speed our car wants to maintain in the face of any external changes. So even if we encounter a hill or a valley or a bump, we still want to strive to maintain that 60 miles per hour. And so anytime we deviate from that 60 miles per hour, there's going to be a signal sent off. We call that the error signal. And that's going to trigger a sequence of events in this scenario that is increasing gas flow to the engine. But understand that that could also be decreasing gas flow to the engine if we happen to speed above our set point. Okay. And so that trigger is now going to bring us back to our set point. And as we get closer to our set point, the error signal becomes smaller and smaller and smaller until it eventually goes away. Okay.